Now I would like to explain you that what is the total number of arrangements possible if R objects are taken at a time out of n number of objects where R is less than or equal to n. So the formula of the permutation, that is NPR. It means that if R items, R objects are taken at a time, if available number of items is n. So obviously this n should be greater than or equal to R. So the result is given by factorial n upon factorial n minus R. So it is simple that NPR, it means that number of permutations or number of arrangements if R objects needed to taken. For example, if you have 7 books of different writers, of different authors of mathematics, and you want to opt 4 books for the preparation of exam. So that will be out of the 7 books of different authors and different publications, you want to opt 3. So it means that this is a combination. But if you want to opt these books in different ways, that is first this book, second this book, so number of arrangements, if 3 objects are to be taken out of 7, the number of arrangements is given by factorial 7 upon factorial 7 minus 3 as per this specification of the result, which become factorial 7 upon factorial 4 equal to 7 into 6 into 5 into 4 factorial upon 4 factorial, get cancelled. This becomes 6 5 are 30, 7 are 210. So there are 210 ways of arranging 3 objects at a time out of a group of 7. So permutation is the linear arrangement. Arrangement is permutation or permutation is the arrangement. If there are 7 objects or 7 students would like to stand in a line, it means that it is a question of linear permutation. So answer is factorial 7. But the arrangement of few things, lesser things if available is more, that is the NPR, factorial n upon factorial n minus R. R is the number of objects to be taken out of n. So this is the formula applicable when we will solve the problems related to permutation. Now I want to explain you the concept that why factorial 0. My purpose is to explain you that why we say factorial 0 is 1. And you also know that factorial 1 is also 1. But if you equate, you will get to know 0 is equals to 1, which is a wrong. So it means that I am going to emphasize you that why this factorial 0 is considered to be 1. Reason is, as I told you that NPR is given by factorial n upon factorial n minus R. In case if I say there are n eatable items available, suppose you have rice, you have vegetable and you have some sweets, and you want to have all 3, but it depends upon the person that in which order one want to have. First sweet, then vegetable, then the third. Similarly, someone can take first rice, then this, then that. So if order matters in answering a question, it means problem is related to permutations. If order is not mattering, problem is of the combination. So here if you have n objects and out of available n objects you want to opt all, and you want to opt in the different orders, then total number of arrangements is factorial n. So ultimately, out of n available objects, you want to take all, but order is mattering, then it means that answer is factorial n. As you want to arrange the 10 items in the row, you want to take 10 out of 10, answer is factorial 10. You want to take 6 out of 6, answer is factorial 6. Similarly, you want to arrange 40 students in a line. So there are arrangements that how many? Factorial 40. The line can be start with any one of the student, which is also being explained to you previously. So if n objects are available, we want to arrange, then we have factorial n ways, and npn. npn means out of n available objects, we want to take all, but in the different order is a separate combination, selection. So this is factorial n. So in place of this formula of npr, if I ask you to replace r by n, what is going to be? npn is equals to factorial n upon factorial n minus n. Because in this result, I am asking you to replace this r by n, then the shape of the formula will be npr goes to npn, RHS factorial n upon factorial n minus r means factorial n minus n. But npn, I have told you, it is factorial n. npn is equal to factorial n and is equals to factorial n upon factorial 0. N minus n is taken as factorial 0. So ultimately what we are opting by the multiplying cross and getting the factorial 0 as factorial n upon factorial n, which is equals to 1, which proves our result that factorial 0 is equals to 1. This was the task to explain you that why factorial 0 is 1. Reason is so simple. We have to know that if n objects are need to be taken out of n, then npn is considered as factorial n, and then applying the formula of npr like this, and this result, replace r by n, we will get factorial 0 is 1.